Hello, students. Good morning. So, as we move forward from our journey through quadratic equations, where we explored the curves, roots, and behavior of the parabolas. So today we step into the something equally powerful, but beautifully simple in its pattern. In quadratics, we study how quantities changes in the curved manner. Now we shift our focus to the situation where changes happen in the steady and the predictable way. This brings us to the new chapter, which is a new concept, and in mathematics, which is called arithmetic progression. So, if we look around us, whether it's the arrangement of the seats in the auditorium, the numbering of the houses on the street, and the steps on the staircase, or even the patterns in the saving and investment, many real life situations follow us regular increase or the decrease. These patterns can be understood and analyzed using the arithmetic progression. So in this chapter, we will learn how to identify the pattern of arithmetic progression and find any term in the sequence and calculate their sums effectively. More importantly, we will see how the mathematics correctly connects directly with everyday life through these simple and powerful sequences. So let's begin this journey of arithmetic progression by first looking at the key agenda and then moving forward to the rest of the slides. Okay, so the key points or the key topics that we're going to cover today as a part of this chapter is that we'll understand the concept of sequence and the patterns. We'll understand what is the arithmetic progression, which we normally call as AP. We'll understand the nth term of an AP and then how we have to find the sum of the nth term of an AP. And then we'll solve all the questions of the exercises which are there in the NCRT and then quick snapshot of what we have learned in this chapter. So let's move to the first slide then. Okay, so before actually understanding the concept of AP, let's understand the concept of the pattern here. So what is a pattern? So pattern is a systemic arrangement of the numbers, shape or the object that follows a specific rule. So there is a specific rule between the preceding number and the succeeding number, and that helps us to draw an inference. And that inference, when we conclude, it becomes a pattern. For example, 2, 4, 6, 8. If we look at the sequence here, it is that every succeeding number is exceeding by 2 from the preceding number. So 4 is increased, 2 is increased by 2, 4 and 6 is increased by 2 from the 4 and 8 is increased by 2 from the 6. So each number increases by 2 and the next number obviously can be predictable as a 10. Or we can say that this is a series of the even number. What is a sequence? Sequence is an order list of the number following the particular rule. For example, let's say we have 5, 10, 15, and we know that these are largely the multiples of 5. So we can predict the next term here. And the basic question arises that why do we study the sequence? So the sequence, it helps in the logical thinking and the problem solving, used in the real life situation like money growth, time schedules, arrangement, etc. And this form the base for the arithmetic progression. For example, if there's a number 3, 6, 9, 12, and if we have to find the next number, either we can say that this is the multiple of 3, we can see that another number is 15, or we can simply say that because every succeeding number is increased by 3 with respect to the preceding number, and hence if we add 3 to the 12, it will become 15. So this is something which we normally call as a sequence in the patterns, and logical arrangement of sequence and patterns we are going to talk about in the next slide, which we normally call as an AP. So we'll move to the next slide. Okay, now we'll talk about the AP, which we normally called as an arithmetic progression. So, arithmetic progression is a sequence number in which difference between the consecutive term is constant. This is very, very important. So, the consecutive terms is the terms which are in order, and then we have to find the difference, and we have to ensure that the difference between the two consecutive number. Let's say if there are three numbers, then difference between the one and two, and the difference between the two and three, and the rest of the difference between the every subsequent number, that is the constant. And this constant difference we normally call as a common difference, which is denoted by the D. This is very, very important. For example, we have number 2, 5, 8, 11, and 3, and we have to find the difference here. If we subtract 5 minus 2, it will give us 3, 8 minus 5 give us 3, 11 minus 8 give us 3. So this is a constant difference, 3, 3, 3, and hence this is a 80. Another example, we have 10, 7, 4, 1. So if we reduce 7 minus 10 minus 3, 4 minus 7 minus 3, 1 minus 4 minus 3. So this is a simple example, but difference is still the common, and hence this is an AP. Now we'll come to the next slide, which is 1496. So 4 minus 1 is 3, 9 minus 4 is 5, 16 minus 9 is 7. So this is not the constant difference across the terms. So hence it is not an AP. So for an AP, a series to be an AP, it has to be the common difference throughout the series. And that difference is known as D. Key component of AP is the first term, which we denote as A. So in a particular series, A is the first term, which is the starting number. Common difference is the D, which is denoted by the D, which is the difference between the consecutive term. And we can create the series with the help of A and D. So when we add A plus D, it will give us the next term. When we add A, so A is the first term. When we add A plus D, it will give the second term. When we add A plus 2D, it will be the third term. When we add A plus 3D, it will be the fourth term. So D is common, and hence we have to multiply the D with the incremental number to get the next number in the series. So here A is equal to 2 and D is equal to 4, and we can create the series A is equal to 2, D is equal to 4, so 2 plus 4, 6. Third term is A plus 2D, which is 2 into 4, 8, 8 plus 2, 10. And then we have the fourth term, which is A plus 3D, which is 2 plus 3 into 4, 12, which gives us 14. This is a typical arithmetic progression. So move to the next slide. Okay. Now we'll going to understand the concept of nth term. This is very important, and also very important with respect to the examination, because a lot of problems is based on this concept. So nth term of an AP is the value of any term with a specific position. So if let's say we have given a series and we were asked to give to find the 20th term or 30th term, then what is the formula that we have to apply? So to find the nth term, we have to apply this formula: A plus n minus 1D, where n is the nth term which is being given in the question, A is the first term, and D is the common difference. So an is the nth term, A is the first term, n is the number of terms, and D is the common difference. So understanding the formula, first term is A, second term is A plus D, third term is A plus D, and nth term is A plus n minus 1D. This is very important because we already have included A here, and hence we have to subtract 1 to get the nth term and multiply it by the D. So for example, if we have the 10th term of the series, so we have first given the series 2, 5, 8, 11. So first we have to verify whether this series is actually AP or not. So we have A is equal to 2, and then D is equal to 3, and we have observed that D is same across, and hence this is an AP. And if this is an AP, we have to find 10th term. So nth term is equal to A plus n minus 1D. So A, which is 2, plus n, which is 10, minus 1 is as per the formula, and D is the common difference. So if you solve this equation, the 10th term is 29. So this is a method through which we can find any term in the arithmetic progression. So we'll move to the next slide. Okay. Now it is equally important to understand the concept of finding the sum. So we have now understood the concept wherein we have to find the nth term. Now we have to also find the sum of the nth term. So what formula then we have to do? So first of all, we have to do, what do we mean by when we term by the sum here? It is the total number of the first nth term of the AP. So instead of adding all the terms one by one, we use the formula, and what that formula is n by 2 multiplied by 2a plus n minus 1d. So this is the formula to get the sum of the n term of the series, where Sn is equal to sum of the first n term, A is equal to first term, D is the common difference, and A is the number of the term. So example, if we have to find the sum of the first 10 terms, so instead of manually adding so first of all we have to find these 10 terms, and then we have to add all those 10 terms to get the sum of the 10 terms. So we can simply use this formula. So in this series, we have A is equal to 2, which is first term. We have D is equal to 3, which is difference between the consecutive terms. We have N is equal to 10, which is being given, for which we have to find this sum. So we'll apply the formula. Sum of 10 number is 10 by 2, which is n by 2, into 2a, which is 2 multiplied by 2, which is a here, plus 10 minus 1, which is n minus 1, into d, which is the common difference. When we solve this, we get the sum as 150. So sum of the n terms and finding the n term, these are like two critical factors to solve any question when we are given the question to solve in the examination. And these are the very important terms that we have to keep in mind. So first of all, a plus n minus 1d, which is the finding the nth term, and then n by 2, and then within the bracket we have 2a plus n minus 1d, which is the sum. So these two are the critical formulas that we need to learn so that we could able to solve any question in the arithmetic progression. So with this, I think we have actually understood the concept of the arithmetic progression, what is arithmetic progression, and then what is the concept of the A, D, and the N. Now we are going to solve the problems which are given in the NCERT book. So let's start with solving the problem by moving to the first exercise. Okay, so we'll solve the exercise 5.1. We'll look at the respective question and solve each question one by one. So first question is, in which of the following situation does the list of the numbers involved make an arithmetic progression by? So we have to find whether the AP exists, and if exists, then we have to say why it is there. So first question is taxi fare after each kilometer when the fare is 15 for the first and 8 kilometer for additional. So which means that 15 is first. So which means that we have given that fee structure is 15 for first kilometer and then 8 for additional kilometer. So for a first kilometer is 15, for additional kilometer is this next is 15 plus 8, 23, and then 23 plus 8, 31, 31 plus 3, 39. So which means that we have A as 15, and then we have the constant difference across the consecutive term, because this is 8 for every additional kilometer. So this truly forms an AP because constant difference is same. So this is the method through which we have to identify whether a particular series is an AP or not. So in this, because the constant difference across the series is same and we have a first term, that means this is a AP. So however, to find the series as AP or not, we have to ensure that the D has to be same, constant difference has to be same. So next question, amount of air present in the cylinder when vacuum pump removes 1 by 4 of the air remaining in the cylinder at a time. So amount of the air in the cylinder is there. Each time 1 by 4 of the remaining air is removed. So which means that remaining air out of that 1 by 4 is getting removed. So which means that a fraction is being applied on every decreasing term. So so let's say if air is there and if 1 by 4 has been removed, so next time the air is 3 by 4. So 3 by 4 of the previous sequence is like 100, 75, 56.25. So every time the application of 1 by 4 is not on the base value, it is on the reduced value. For example, if let's say air was 100 and then we have removed the 1 by 4, that means that it has become now 75. Now again when we have removed 1 by 4 of 75, the air would become 56.25. So which means that the difference between the first and the second is 25, but the second and the third is not 25. So which means that constant difference is not the same, and hence this is not an AP. So we move to the next slide. Okay, now third question. So we have been given the cost of digging a well. The cost is 150 for the first meter, so which is the constant, and then it is going to increase 50 for each meter. So which means that for each additional meter, the cost will increase by 50. So in this case, for example, if it is 150 for the first, then definitely it will increase by 50 for next meter, which is 200. It will increase by 50 by another 250. So which means that the constant difference or the common difference is across the same year, 50, and hence because constant difference or common difference is same, therefore this is an AP. Next is amount of the money in the account increases by a fixed amount. So typically, for example, we have a fixed deposit in every period and it is increasing by the fixed amount. So again, the difference is constant and hence this is an AP, increase is constant at each time. So the thumb rule is that if at all we have the constant difference and then constant difference is same across the series, then the series is an arithmetic progression. So we are coming to the next question. So we have given a set of the 5 problems here, wherein we have write the first 4 term of the AP when the first term and the common difference are given below. So we have to write the first 4 term. We'll move to the next slide and see how we have to solve this question. Okay, now we'll solve this question one by one. So what we have given, A is equal to 10, D is equal to 10. So again, first term is 10. Then we have to add the common difference A plus D, A plus 2D, A plus 3D. We have the other terms. Likewise, if A is equal to minus 2 and D is equal to 0, we have to use the same formula. So we can use this simply. So first term is A, next term is A plus 2D, A plus D rather. Next is A plus 2D, and next we have A plus 3D. So we'll use this formula to define all the terms. So likewise, we'll solve this equation and we'll get all the terms that has been given. We have to be very much cognizant of the fact that wherever minus are there, it is still an AP and we have to solve it appropriately so that we should not be confused by this sign. So A plus D, A plus 2D and A plus 3D. These are the first 4 terms of the arithmetic progression and we have to solve by using this formula, or you can simply add the first common difference to the first term and then add the common difference for each consecutive each term to get the next consecutive term. This is how we have to solve the question. So we'll move to the next slide. Okay, so we'll come to the next question then. What we have to solve here, for the following AP, write the first term and the common difference. We have to find the first term and the common difference. So this is a series. So first term is A, which is equal to 3, and then we have to find the common difference. So 1 minus 3, which is equal to minus 2. We can verify it whether minus 1 minus 1 minus 1 minus 1 is equal to again minus 2, minus 3 minus minus 1 is equal to minus 2. This is a constant difference. So second term is minus 5 minus 1. So again, first term is minus 5. Common difference is minus 1 minus minus 5, which is equal to 4. Third question is uh, 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 third is 1 by 3, and then we have 5 by 3, then we have 9 by 3, then 13 by 3. These are the terms here. So first term is equal to 1 by 3. Common difference is 5 by 3 minus 1 by 3, which is equal to 4 by 3. Answer is A is equal to 1 by 3 and D is equal to 4 by 3. Then we have fourth, A is equal to 0.6, common difference 1.7 minus 0.6, 1.11 minus difference. So this is the answer to the question. So we move to the next question. Okay, so in the next question, which is question number 4 of exercise 5.1, what we have to do, we have to find the which of the following. First of all, we have to find whether the series is AP, and if they form an AP, find the common difference and write the 3 more terms. So we have to find the whether series is in AP or not. If yes, then we have to find this common difference and then the next 3 terms. So we'll solve this question one by one. So first is 2, 4, 6, 8, 12. Difference is 2, 4, 8, which is not constant because 4 minus 2 is 2, 8 minus 4 is 4, 16 minus 8 is 8. So constant difference is not there, so hence this is not an AP. Next is 5 by 2, 7 by 2, 9 by 2, 11 by 2. So constant difference is 1, 7 by 2 minus 5 by 2, which is equal to 2 by 2, 9 by 2 minus 7 by 2 is 2 by 2, 11 by 2 minus 9 by 2 is 2 by constant difference is 1, and this is an AP. And then next term is 11 by 2 plus 1, which is equal to 13 by 2, 13 by 2 plus 1 is 15 by 2, 15 by 2 plus 1 is equal to 17 by 2. So we'll move to the next slide. Okay, so next question is minus 1 by 2, minus 3 by 2, minus 5 by 2. Again, when we look at it, so we'll find as minus 3 by 2, minus 1 by 2, which is equal to 2, minus 5 by 2, minus 3 by 2 is 2. So common difference is same, and hence this is an AP. Then if it is an AP, we have to find the next term. So minus 7 by 2, minus 2, which is equal to minus 9 by 2, minus 9 by 2, minus 2 is minus 11 by 2, minus 11 by 2, minus 2, minus 13 by 2. These are the next 3 terms. Likewise, we have to find the difference. So D is same. Hence this is an AP, and these are the next 3 terms. Again, for this, we have find that common difference is root 2, 3 plus root 2 minus 3 is equal to root 2, 3 plus 2 root 2 minus 3 plus root 2, which gives again the root 2. So hence the common difference is same. So we which is root 2, then we can find the next 3 terms. So in this, common difference is not the same, and it's not an AP. In this, again, the common difference is same, which is minus 4, and then we have to find the next 3 terms. So like this, we have to solve this problem. We'll move to the next slide. Okay, so we have the next sum here. We have to follow the same method here. So we have to find the D here. So D is equal to 0, which is constant, and then we have to find these same 3 terms. So it's same because difference is same. Again, in the next term, difference is not the same, and this is not an AP. In this, difference is same, which is A. Then we have to find the next term. So 4A plus A 5A, 5A plus A 6A, 6A plus A 7A. So in this, common difference is not the same, and this is not an AP. So in this, we have find that common difference is same, which is root 2, and then we have to find the next 3 terms. So we'll move to the next question. Okay, so we have root 3, root 6, root 9. We have to find the difference is not constant because root 6 minus root 3 is root 6 minus root 3, and because this cannot be solved, and hence this is not an AP. Again, in this, common difference is not the same, not an AP. And in this, we have find as 1 square, 1, 5 square, 25, 7 square, 49, and then 73 and all those things. And when we find the difference, this is coming as constant, 24. And then we have to find the next term by adding that in the next term when there's 73 to get the next terms. So this is how we have to solve this question. We'll move to the next question and see how we have to solve it. Okay, now we'll come to the next exercise, which is exercise 5.2. So we have given a table wherein we have to find the missing term. So in this first we have to find the AN. In the second question we have to find the D. In the third question we have to find the A. In the fourth question we have to find the N. And in the fifth question we have to find the AN. So we'll solve each of them separately. So in the first question we have given A is equal to 7, D is equal to 3, and we have to find N. So N is equal to 8. It is given. Sorry, it's N is given to 8. So we have to find the eighth term here. An is nothing but the eighth term. So what is the eighth term? Is A plus N minus 1 into D. So our A is equal to 7, n is equal to 8 minus 1 is the formula into d is equal to 3. So a eighth term is 28. So in the second question, we have given a as minus 18. We do not have d, but we have the n is equal to 10, and we know that nth term is 0. So we know that 0 is equal to minus 18 plus 10 minus 1d, which is nothing but n minus 1d. When we solve this, we'll get the value of d, which is equal to 2. In the third question, we have given d is equal to minus 3, n is equal to 18, and a n is equal to minus 5. We do not have the a here. So we'll put that in formula. So we have the minus 5, which is the nth term. And we have given that a plus n minus 1, n is given to us as 18, and minus 1 is as per the formula into d minus 3. When we solve this, we'll get a is equal to 46. In the next question, we have given a is equal to 18 point minus 18.9, d is equal to 2.5, and nth term is equal to 36. So we have to find the n here. So we know that nth term is equal to a plus a, which is minus 18 and plus n minus 1d. When we solve this, we'll get n is equal to 10. So n is equal to 10 in this question. So we'll move to the next slide. Okay, so last one we have given a is equal to 3, 3.5. We have given d is equal to 0 and n is equal to 105. When we solve this to get the value of the an, we'll get the sum of, let's say, nth term is equal to 3.5, which seems to be a bit incorrect, but that is how it has to be solved because it's a fraction. But that's fine. We can solve it because a is anyways 3.5. So n is equal to, also when we solve this, we can 3.5 as well. Okay, now choose the correct choice in the following question. So what we are given, we have to find the 30th term of the AP. We have to find the next value over here, 11th term of an AP, and then we have to find the next value over here. So 30th term of AP 1074. So first term is given as 10. We find the common difference as minus 3, and then we have to find the we are given n is equal to 38. We will find the value of a30, which is equal to a plus n minus 1d. When we solve this, we'll get the value as minus 77. So in the next one, we have given the series minus 3, minus 1 by 2, and henceforth like this. So we have the value here. So minus 7, okay. So minus 3, okay. Then we solve it. We have the a is equal to minus 3. So this is the second question. This is the second question here. Okay, so a is equal to minus 3 minus 1 by 2. When we solve it, we get the a is equal to minus 3. We have to find the d is equal to 5 by 2. And when we have to find the 11th term, we solve it by the formula a plus n minus 1d. When we solve it, we get the correct answer as b, which is 22. This is how we have to solve this question. Okay, so now in this question, we have been given that series is in AP, and then we have to find the missing term. So we'll solve it one by one. So first is 2 question mark 26. So let the term be x. So 2x and 26, this is an AP. And if this is an AP, then we have the common difference. So we know that x minus 2, which is the second term minus first term, is equal to 26 minus x, which is like third term minus second term. When we solve it, we get the value of x is equal to 14, sorry. And then when we can verify it that, so 2, 14, 26, the common difference between 14 and 2 is 12, and the common difference between 26 and 14 is 12. So this is correct. Now we have given the next question. We have a question 13 in question 3. So again, we can create a series. Let the terms be a and b. So a 13, b 3, and then we know that there is a common difference, which means that 13 minus a should be equal to b minus 13, should be equal to 3 minus b. Now we'll solve the second and third portion of it, which is like 3 minus b is equal to b minus 13. On solving it, we get the value of b is equal to 8, and then we'll compare this value with the 13 minus a is equal to b minus 13 equation, and when we get the value of a as 18. And when we put it in the series, we get the 18, and then we get the next term as 13. Then we get the next term as 8, and then we get the next term as 3. So when we try to solve it, so 13 minus 8 is equal to minus 5, which is the common difference equal to minus 5. 8 minus 13 is equal to again minus 5, so which is like common difference same, and then 3 minus 8 is equal to again minus 5. So which means that this answer is correct. So we have to find the answer, then we can verify it is verify the answer by putting it in the value of the d, and then we can verify whether this is a correct or not. So we'll move to the next question. Okay. Now we have another question here where we given 5 question 19 by 2. So again we'll put the series 5 AB 19 by 2. And again, we have to solve it the way we have been, like a minus 5 is equal to b minus a is equal to 90 minus 2 minus b. So we'll solve this equation to get the value, and we get the value as 13 by 2, 8, 19 by 2. Now, next question is very, very important, and here we are going to use some formula here. So, now in this question, we have given the minus 4, and then we have given the 4 terms which are missing, and then we have given the 6. So, how we have to solve this? So, we have to first find the total term. So, where total term is equal to 1, 2, 3, 4, 5, 6. So, we have 6 terms, right? So 6 terms, which means that apart from A, there are 5 gaps. So we can have A, we know that minus 4, then we have the 5 gaps. So every term will have gaps less than the number of the one less than number of terms. So if we have total 10 terms, that gap would be 9 because we have A as the first term. So in this question, we have minus 4 as the first term. We have 6 terms, and then the gap is 5 gaps. So whenever we have this number of the gaps been given, so how we have to solve here is that we have to first find the D here. So how we have to find the D here? The last term which is being given in the series. Okay, and then we have to subtract it from the first term which is given in the series is minus 4. Divide by the number of the gaps. This is very, very important. This will help us to find the D. So how we have to solve it? The last term which is given in the series minus the first term divided by the number of the gaps. So we'll have the gap of 2 within the series, and then we'll apply this gap in the first term. So minus 4 plus 2 give us 2, minus 2 plus 2 gives us 0, 0 plus 2 gives us 2, and 2 plus 2 gives us 4. This is the final series. This is very, very important because we have to use this formula when we do not have the number of missing, when we do not have missing terms only one, but we have multiple missing term in this series. So we have to use this formula to get the final answer here. So again, here we can use the same logic here. So we have the first term as A. We have how many terms? 1, 2, 3, 4, 5, 6. So 6 terms are there. So there are 5 gaps. So again, we can 5 gaps, but we have given the 38 as the first term. So in this case, if we go with the 38 as the first term, then we have 1, 2, 3, 4. So we have the 4 gaps here. So we'll apply this formula because we have to take 38 as the first term and minus 22 as the last term. So D is equal to minus 22 minus 38, which is the last term and the first term with respect to this series. When we apply this, we get the formula as answer as D is minus 15. And then we have to move backward. So to get the answer of before 38, we have to add 15 to it because succeeding term is less than the preceding term. So preceding term has to be more. So our difference should be added back to get the first term. This is very, very important. So basically, this is also very, very important concept. Then whenever we are giving a missing term, we have to see that whether consecutive terms are missing. Then we have to apply the formula wherein we have to do the L minus A upon D, L minus A upon number of the gaps. But that has to be sure that whenever we are taking the A, that is to be the first term. If it is the if it is not the first term, then we have to drive the first term here. So we'll move to the next slide. Okay. So in this question, which term of the AP is 78? So what we have given the A, we can find the D. We do not have the value of N, but we have the value of AN. So AN is 78. We have the A as 3, we have the D as 5. So we'll simply apply the formula to get the value of N. So AN is equal to A plus N minus 1D. So AN is given as 78. 3 plus N minus 1D. When we solve it, we get the value of N as 16. Next is find the number of the term in each of the following. So we have to again find the n here. We have given the nth term. We have given the a and d. So first term is a, common difference is 6. We have given the 205 as nth term. Solving it with the help of the formula, we'll get 34 term. So n here is 34. Okay, so coming to the next question then. So we have given a series 18, 15, 1 by 2, 13, so on. First term is given as 18. Common difference we have to find, which is uh, 15 1 by 2 minus 18. When we solve it, we get the value as minus 2.5. We are given the nth term as minus 47. When we solve it, we'll get the n as 27. 27th term is minus 47. So in the next question, we have to check whether the minus 150 is the term of the AP series or not. So we'll use the same formula here. So an is given minus 150. We have given a is equal to 11. N is equal to, we have to find that. And we have d is also given as minus 2. When we solve it, we get the value of n as a fraction because it is not a whole number. And hence, hence this 1 minus 150 term is not a term in the AP, which is being series of 11, 8, 5, and 2. So absolutely, we have to make sure that if it is not in a whole number, then it cannot be term in the AP. So we'll move to the next slide. Okay, so again we have a question here. We have find the 31st term on the AP whose 11th term is 38 and 16th term is 73. So we have to use the formula here. AN is equal to A plus A1 N minus 1 D. So when we give 11th term is nothing but the A plus 10D, because when we put 11 in the N, we'll get 11 minus 1, which is 10. So A plus 10D is given to 38. And likewise 16th term is 73. So A plus 15D is equal to 73. When we solve this equation, we can get the value of D is equal to 7. And when we substitute that value in any of the equation, we get the value of A as minus 32. And when we have to find the 31 term, so we'll simply use the formula A plus 30D. To solve it, we'll get the value, and which is value is 178. So it's very simple. We have to first solve for the 11th term and the 18th term, 30 and the 30th term, and then we'll get the 11th and the 16th term, and then we get the value of the A and D. We'll substitute that value to get the value of the 31st term. Next question is that in an AP consists of 50 term, which third term is 12 and last term is 106, finally 29 terms. So we'll solve this in the next slide. Okay, so our formula is A plus N minus 1D. So we have to form the two equation here. From the third term, A plus 2D is equal to 12. Fifth term is A plus 39 is equal to 106. When we solve this, we'll get the value of A as 8. And when we substitute the value of there to get the value of the D, we'll get the value of D as 2 and the value of A as 8. Then we can find the 29 term, which is nothing plus, which is equal to A plus 28D. We get the final answer here. Again, in the next question, third term and the ninth term are given. We have to find which term in the AP is 0. So first we have to find the value of A and D. So we are saying that A3 is equal to 4, E9 is equal to minus 8. We'll put them into the A plus N minus D1 form, and then we'll get the value of A and D, and we'll solve it. We'll move to the next slide to find the solution. Okay, so we'll use the same formula here, A plus N minus 1D. When we solve it, we'll get the value of D as minus 2, value of A as 8. And then we have to make sure that A plus N minus 1D is equal to what we have to find that. So we'll get the value of the 0. So we have to put the 10th, the fifth term is 0. We have to find the value by putting this value into the any of the equation to confirm that which term an is equal to 0. We put the nth term as 0 and solve it with the help of the a plus n minus 1d formula to get the value as 0. The seventh term of the AP exceeds the 10th term by 7, find the common difference. So 17th term exceeds 10th term by 7. So 7th term minus 10th term is equal to 7. This is a simple equation. So 7th term will use this formula, 17th term and the 10th term, and we'll get the value as 7. We'll move to the next slide and see the solution. So we have given the term here. So A17 is equal to A plus 16D, A10 is equal to A plus 9D. We'll use the formula, which means that 17th term minus 9th term is equal to 7. Solve it, get the value of the D. Which term of the AP will be 132 more than its 54th term? So we are given the AP as 3, 15, 27, 39. First term is A, common difference is D, which is 7, 12. If we find the 54th term, which is A54, which will solve with 639. Now we have to say, we are saying that will be 132 more than the 52 term. So we'll add 132 to the 54 term. The term is 771. We have to get the value of n here. So an is equal to 771. When we solve it, we get n is equal to 65. So 65 term is 132 more than the 54th term. This is how we have to solve the equation. So we'll move to the next one. Okay, so we have another question here. So what we have given, two APs, there are two series of APs which has the same common differences. Difference between their 100th term is 100. We have to find the difference between their 1000th term. So we know that formula is A plus n minus 1d. So let's say first AP is equal to first 100 term of the first AP is equal to A1 plus 1990, and second AP we have A2 plus 1990. We have given that 100 is the difference between their 100th term. So that means A1 plus 1990 minus A2 plus 1990 is equal to 100. So we have given A1 minus A2 is 100. Now we have to find the difference between the 1000 term. So we'll again use the formula A plus 990 A2 minus 990. When we solve it, we get the value of A1 minus A2. And now this A1 minus A2 is also has been evaluated. It is giving 100. So which means that the difference between the 1000 term is also equal to 100, because we have to substitute the value of A1 minus A2 in this equation, which is already 100 we have derived from the first equation. So difference in the 1000 term is also 100. So we'll move to the next slide. Okay. Now we have another question. Question we have is how many three-digit numbers are divisible by 7? So how we have to solve it? So first and the we have to find the first and the last multiple of 7. The smallest three-digit multiple of 7 is let's assume we have 100 as the smallest three-digit number. We'll divide by 7, so we get 14.28. So typically when we multiply, we can take it as whole number. We'll take it 15. So we have 15 and 15 multiplied by 70105. So which means that 105 is the first number in the three-digit which is divisible by 7. So this will help us to divide the value of a here. So our a is equal to 105. Likewise, we have to find the largest three-digit multiple. So we'll take 999 divided by 7. When we solve it, 142 by 7. So we have to round it down. So 142 into 7 which is 994. So this is the largest number of three-digit which is divisible by 7. So we have the last term which is known as 994. So first term is 105 and last term is 194. So what we have to then do, we have to form an AP because our AP is 105 plus 7 plus 7 and then we get the value of 9. So A is equal to 105, D is equal to 7 and last term is equal to 9. So we have to use the nth formula. So we'll use the nth formula A plus n minus 1D. So last term is equal to 994, A is equal to 105, n minus 1 is the formula, multiply by D. When we solve it, we'll get the 128. So there are 128 three-digit number which is divisible by 7. This is how we have to solve this question. So move to the next slide. Okay. So now in this question, what we have to do, we have to find how many multiples of 4 lie between 10 and 2. So again, we have to find that factor here. So first multiple of 4 which is greater than 12 is obviously 4 3s are 12. So which means that our value is 12, which is the A here. And then we have to find the last multiple of 4 which is less than 250. When we solve it, we get it 248 and this is the last multiple, last value of multiple which is like a number which is like 62nd number in the series. So starting from the 12 and then we have the last number as 248. First number is equal to 12, common difference is equal to 4. When we solve it, we'll get the n value which is equal to 60. So there are 60 multiples of 4 between 10 and 250. So next question is for what value of n the nth term AP 63, 65, 67 are equal. So first of all, first AP is equal to 63, 65, 67. First term is equal to 63. Common difference is equal to. And second AP we have uh, 3, 10 and 17. So second AP is equal to, it is equal to 3 and common difference is equal to 7. So move to the next slide then to see these next the solution here. Okay, so what we have then given, we have given that we'll put this into the value as the equal because we have to equate both this together. So what we're going to do then, so we are saying that a n is equal to a plus n minus 1d and then a n is equal to a plus n minus d. We have to put these value as equal because we have to find the value of n wherein both these two terms have equal value for that particular nth term. So when we solve it, we'll get the value of n is equal to 30 and we can verify it by putting the n in the first series and second series and then that value is equal to common value for both the series. Next question is determine the AP whose third term is 16 and seventh term exceeds the fifth term by 12. So again we have a n is equal to a plus n minus 1d. So we have given that a plus 2d is equal to 16 and again when we solve it with the help of the example here. So basically this is as simple as this similar question that we have solved earlier. 7 term exceeds the fifth term by 12. So a7 minus a5 is equal to 12. When we solve it, we get the value and then we get the value of t is equal to 6 and then we see the rest of the solution in the next slide. Okay, so we'll substitute that value, we'll get the value of a is equal to 4 and then we can create the series with the same a and d. Find the 20th term from the AP. So again we have given the AP, we can find the a, we can find the d, last term is equal to 253, we'll put into the equation, solve it and get the value as 158. Next is sum of the fourth and the eighth term of AP is 24. Sum of the sixth and tenth term is 44. By the So this is like very simple. We have to create the equation. We have to solve this equation and get the answer because this is a chapter which is ahead of equation in two variable, and we know that how we have to solve the equation in two variable to get the value of A and D. This is what it is. So move to the next slide. Okay, so we'll solve it. What we have given, we are given a plus a4 plus 8 is equal to 24 and a6 plus 8 is equal to 24. We'll put those values, solve the respective equation, and then we get the final answers, and then we get the first three term of the equation as well. Now we have to look at the next question. Shubha Rao started work in 1995 at an annual salary of 5,000. Receive an increment 200 each year. In which year did he income reach 7,000? So we'll go to the next slide and look at the solution. So we'll use the simple formula here. So A is equal to A plus N minus 1D. We'll have the value of A, which is 7,000, which is the value base that we have given. Starting A is 5,000. N is, we have to find the N here. And when we solve it, we'll find that N is equal to 10. N is equal to 11 rather. And when first term is equal to 1995. So total term is equal to 11 years. So 1995 plus 10 years equal to 2005. So in the 11th year, his value would become 7,000. So we are in the first year, we have to add 10 more year to get the value of 11. Final answer, his income reached 7,000 in year 2005. See why we have to put, we have find the value of n is equal to 11. So 11th term is equal to 7,000. 11th term is equal to a plus 10d. We are already given that a is 5,000. So we have to find the value of the year in which his income would be 7,000. So he is already in the first year, which is 5,000, which is a, and then 11 minus 1, which is equal to 10d. So 10th in the 10 year from this year, which is 1995, his income would be 7,000 rupees. Ramkali saved 5 in the first week of the year and then increased her weekly saving by rupees 1.75. If in the nth week her savings has become 20.75, find the end. So again, A is equal to 5, D is equal to 1.7, A is 20.75. Solve this equation with the help of the formula. You'll get the value of N is equal to 10. Okay, now we'll come to the another exercise, which is exercise 5.3, and here we are going to talk about for the calculation of the sum. So we have already understood the concept of nth term and how to find the nth term. Now we are going to understand the concept of sum of the series in the arithmetic progression. So we have set of the questions. So we have 4 questions here. As a part of the first question, we have 4 subpart to it. We have to find the sum. So the series which is being given to us is 2, 7, 12, and we have to find the sum of the first 10 terms. So A is equal to 2, D is equal to 5, N is equal to 10. We have to apply the formula S10 is equal to N by 2. In brackets, we have 2A plus N minus 1D. When we solve this, we get the sum of the first 10 term of the series as 245. Likewise, for second, third, and fourth, we have to find the sum with the help of the same formula. So we move to the next slide. Okay, so again in this we have to find the sum of the series. But I think the missing term here is that we do not have the n here. So first we have to find the n. So we have given the last term as 84. We have a as 7. We have to find the first the d, and the once we have the d with us, we can find the value of the n. So last term is a plus n minus 1d, so, which is 84 is given to us. A is 7 and n minus 1d, which is like 3.5 when we have calculated it. So we have to find the first n. So we have the n as 23. Then we have to find the sum of the first 23 term while substituting this value of n into the actual formula of n by 2 into. So basically in this we can also use this formula. So if we have the first term and the last term being given, so instead of using the formula a l n by 2 into 2a plus n minus 1d, we can also use this formula. So this is a kind of another formula which we can use to find the sum of the AP, which is n by 2 into a plus l. So that will help us to find the sum of the total term of the series. Okay, and then we have to solve this problem as well, 34%. So again, we have to find the same logic here, and we'll use the same formula to find the sum of the series. So we'll move to the next slide. Okay, so now this is the third question of the first, third sub question of the first question. So again, we have to use the same logic here. A is given, D is given. We have the value of the L. We'll use the same formula to find the sum of the series. Now we have set of 10 questions here. So we have given A, D, and nth term is equal to 50. We have to find the nn essence. So we have to find the multiple things here. So we'll solve each one of them individually in the next slides. So we'll move to the next slide. Okay, so we have given A is equal to 5, D is equal to 3, A is equal to 50. First, we have to find the value of the n here. We'll get the value of n as 16, and then we'll use the formula to derive the value of these sum of the we are again using the same logic a plus l n by 2 into a plus l to find the value of the sum of the series. So again a is 17, 7, a 13 is 35. First of all, we have to find the value of d. We'll find the value of d here, and then we use the value to find the sum. So in the next question, we have given the 12th sum as 37, d is equal to 3. We have to find the value of the a here, so we have to find the value of a as 4, and then we use the same value to find the first 12 term. So in the next question, we have given third term as 15. Sum of the first 10 term is 125. So a plus 2d is equal to 15. And then we have 125 is equal to sum of the first 10 terms. So n by 2 is equal to 10 by 2, which is equal to 5. 2a plus 9d is equal to the last term a plus L, and then when we solve it, so a plus L is equal to a plus 2d. So a plus 2d will give us the value as 25. When we solve it, we'll get the value and substitute the value into the respective term to get the value of d, and the 8 n is equal to 8. So we'll solve this and get the respective values. So for each of the question, ideally we have to use the same formula. Either we have given the nth term, or we have given the n, or we have given the d, or we have given the a, and then we have to derive the value of either d, a, nth term, or value of the n, and then we can use those values to find the sum of the series. So we'll move to the next slide. Okay, so again, same concept here. We have given the d and Sn is equal to 75. We'll substitute that value to derive the value of the a, and then one can use this value to derive the next term in the ninth term in the series. In the next question, we have given a is equal to 2, d is equal to 8, Sn equal to 90. We'll solve it with the help of the equation, and then we get the value of n is equal to 5 and a is equal to 34. In the next question, we have given a is equal to 8, an is equal to 62, Sn is equal to 210. We'll again use the same logic. We'll use the formula of n by 2 a plus l, and we'll solve it. We get the value of n is equal to 6 and 10.8 as the value of the d. In the next question, we have given nth term as 4, uh, d is equal to 2, and sum of nth term is minus 14. We'll first find the value of n. Once we solve the value of n, we can use this value of n. So we have a quadratic equation here, and we have to use the positive value of n. We can ignore the negative value. So n is equal to 7. When we solve this, we'll get the value of the respective term that is required to be as a part of this question. So we move to the next slide. Okay, so in this question again, we have given a value of the a as 3, n is equal to 8, s is equal to 192. We'll solve it. We get the value of d as 6. And likewise, in the 10th question, we have given the l as 28, s as 144, n is equal to 9. Solve it with the help of the respective equation, and then we have the value of the a is equal to 4. Next question, how many terms of AP must be taken to give the sum of 636? So we have to find the value wherein sum is given 636. We'll substitute sum as 636. We have given A as 9, D as 17 minus 9, which is 8. When we put that value, we'll get the value of n. So n of value is 13.2, which is not an integer. So no whole number term is given sum exactly 636, which means that as per this equation, we do not have a whole number. The value of n is 13.25. So which means that this is a number between 13 and 14, but this is not a whole number. So no whole number terms gives the value exactly equal to 636. So we'll move to the next slide. Okay, next we have this question. The first term of the AP is 5. We have given this, and the last term is 45. Sum is 400. We have to solve it. So we'll again use the formula s is equal to n by 2 a plus l. We'll get the value of n is equal to 16. We'll put this value and get the value of d as 8 by 3, and final number is n is equal to 16. D is equal to 8 by 3. Next question is first and the last term of 17 and 30 to be given. We have given common difference 9. How many terms are there? And we have to find the sum. We solve with the help of the equation, and then we get the final answer. N is equal to 38 and sin is equal to 6973. So we'll move to the next slide. So in this slide, again, we have given that find the sum of the first 22 term of the AP. D is equal to 7. 22nd term is equal to 149. We'll solve this equation with the help of the given formula to get the value of a. When we get the value of a, we can put it into the value of Sn 0 n by 2 to l, a plus l to get the value of the sum. So the sum is equal to 1661. Next is find the sum of first 51 term of the AP whose second and third term are respectively 14, 18. So A is equal, whose sum of second and third term are okay. So we have given the first we have the common difference find the A. So D is equal to A3 minus A2, which is given that 18 minus 4. A2 is equal to A plus D and A plus 4A is equal to 10. So we solve this, we'll get the value of the A is equal to 10. Second term and third terms are 14, so difference is equal to 4. So A plus D is equal to 14 when we get the value of A. When we put the value of A and D in the sum, we'll get the sum as equal to 5610. Okay, so in this question, what we have to do, this first sum of the first 7 term of AP is 79 and that of 17 term is 29. We have to find the n term. So for n is equal to 7, we have the first equation, we'll solve it. For n equal to 17, we have the second equation, we'll solve it. Solve this both equation to get the value of A and substitute that value to get the value of D. And then we have to find the general sum. So Sn is equal to n by 2, 2a plus n minus t. When we solve this entire equation, we'll get n square. So that A1, so this is the n square is equal to sum of the general term. So next one we have to find it, show that A1, A2, An form an AP and define the values below. So we'll move to the next slide to find the solution. Okay, so in this question, we have given An is equal to 3 plus 4n. So first of all, we have to find the next term. So next term is equal to 3 plus 4n plus 1 because next term is n plus 1. So we'll put that value as 4 into n plus 1. We'll solve it. We'll get the value as 3 plus 4n plus 4. So this is our next term, which is n plus 1 term. When we find the common difference, which is a n plus 1 minus an, we'll get the common difference as 4. So next we have to find the first term, which is a plus a plus d, which is that of 7, and then we have to find the first sum of the first 15 term. We'll put that formula to get the final sum of first 15 term. So AP with D is equal to 4 is equal to 525. Similarly, for 9 minus 5, when we have to gain n plus 1 term is equal to, we have to find that value and then we have to find the value of uh, 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 D here. So wherein D is equal to minus 5. When we solve it, we get the first term is equal to 4. When we put this value, we get the value as minus 465. So again, here we have to note two important points here, that we have to first find the value of n plus 1 term. So, and when we have the value of n plus 1 term and when we have the value of n plus n term, we can get the value of d here. And the moment we find the value of d, what we can then do, we have to find the first term, which is like 3 plus 4, which is equal to 7, and in this case is 9 minus 5 because our common difference is minus 5. And when we get these terms, we can create the series. And once we have created the series, we have the value which is given to us. And then we can use that value to derive the sum of the series. Okay, so in this question, what we have to solve for? If the sum of the first n term of AP is equal to 4n minus n square, what is the first term? That is S1. What is the sum of the first two term? What is the second term? Similarly, find the third and the 10th term. So what we have given, Sn is equal to 4n minus n square. So An is equal to Sn minus Sn minus 1. So first of all, we have to find the sum of the first term. We'll put S as value of n as 1 here, and then we'll find the sum as 3. Now we'll have to find the sum of first two term. We'll put the value of 2 in the place of n. We'll get the value as 4. So sum of first two term is 4. Sum of first term is 3. So which will get the help of, we can get the value of A2. So what is the value of the A2 in this case is equal to S2 minus S1, which is equal to 1. So which means that our value was 3, which is sum of first term. Sum of two term is 4, which means that value of the second term is 1. That's why, because 3 plus 1 becomes 4. So which means that our value of the second term is 1. So hence our value is equal to 4 for the sum of first two term. Likewise, we can find the value of S3, which is sum of first three term, by putting the value S3 minus S2, or we can simply put the value at 3 here. So 4 is a 12 minus 3 square 9. So 12 minus 9 will give us the value of 3. So we have the sum of first three term is equal to 3. And then we can value over the A3. A3 is nothing but the sum of S3 minus sum of S2. Sum of S3 is equal to 3. Sum of S4 is equal to S2 is equal to 4. We'll get the value of A3 is equal to minus 1. So likewise, we have to find the sum of first 10 term. We'll put the value of 10 in the place of n. Sum of 9 term, we'll put the value of 9 as the place of n. And then we have to find the sum of the nth term. So we'll put the value of n here as Sn minus into s minus 1. An is equal to Sn minus s minus 1. We'll solve the equation. When we solve the equation, we get the final answer as minus 2n plus 5. So this is the sum of the so this is the nth term rather, not the sum of the term. This is the nth term. So n nth term is equal to sum of n minus sum of n minus 1. When we solve this, we get the nth term, which is equal to minus 2n plus 5. We'll move to the next slide. Okay, next question is there. We have to find the sum of the first 40 positive integers, which is divisible by 6. So we have given a is equal to 6 as the first term because first is 6. Common difference again 6 because these are the multiples of the divisible by 6. Now number of the terms which is given is to 40 here. We'll put that value here and solve it. We'll get the value as 4920. Find the sum of the first 15 multiples of 8. So the first 15 terms is given. Sum is we have to find the formula. Then we have to given that multiple of 8. So first term is equal to 8. Common difference is also equal to 8. When we put that value in the equation, we'll solve it. We get the value as 60. Find the sum of the odd numbers between 0 and 50. So first number is 1 and then every number is incremented by 2. So d is equal to 2. When we solve it for the value, we get the final answer as 621. We'll move to the next slide. Okay, so in this question, what we have given, so we have been given a contract or a construction company job specifically a penalty for the delay for the completion beyond a certain date, 200 for the first day, 250 for the second day, 300 for the third day. The penalty for each succeeding day being 50 more than the preceding day. How much money the contractor has to pay as a penalty if he has delayed the work beyond 30 days? So penalty from NAP. So first the penalty is 200. Common difference is given as 50 because it's incremented by 50 every day and number of days is 30. So find the last term. First of all, we have to find the penalty that is being given on the 30th day. So that is total, which is going to 1650, and find the total penalty. So we'll use the formula A and into S n by 2 is A plus L. We'll solve it. So total penalty is 27,750. Next question, sum of 700 is to be used to be given 7 cash prizes to the students of a school for the overall academic performances. If each prize is 20 less than its preceding price, find the value of the prizes. So we have given this sum of the 7 prizes 700. Number of prizes L is equal to 7. Each prize is 20 less than the previous. So we have D is equal to minus 20 here. Let the first prize be A. We use the same formula here. When we solve it, we get the value of A is equal to 160. So each price is 20 less than. So 160 minus 1 for minus 20 minus 20. Likewise, this is the total 7 prizes that we need to distribute. So we'll move to the next slide. Okay, so we have another question here. So the question is that in a school, we have given that there are students sort of planning to planting the trees around the school. So in this question, what we have given that. So classes 1 to 12, total number of students is 1 to 12. Each classes has 3 sections. Each section plants number of the trees is equal to the class number. So total trees is equal to, so we have 3 section. We have, and what we are saying that each section plants number of the trees is equal to the class number. So we have the number starting from 1 plus 2 plus 3, and then we have the total 12 classes. So we'll first calculate that. Sum of the first 12 natural number is equal to 78 with the help of the formula a plus a by 2 a and s n is equal to again n by 2 2 plus n minus 1 d. We'll solve it to get the sum of the first 12 natural number, sum of the first 12 natural number, and then multiply by the section by 3. So we'll have total 234 trees to be planted. Next question, a spiral is made up of the successive semicircle with the center alternatively A and B starting with the center A. So these are the radius that is given in the figure. Then what we have to find, what is the total length of the spiral made of the 13 consecutive semicircle. So length of the one semicircle is equal to pi r, which is nothing but the circumference of semicircle. So the total length is equal to pi multiplied the sum of the radii. So we'll move to the next slide to look at the solution here. Okay, so sum of the radii is equal to, we have a is equal to 0.5, d is equal to 0.5, and is equal to 30. We'll solve it. We'll get the value as total length, and we'll multiply that with by pi to get the final answer. So next question, 200 logs are stacked in the following manner as below. 20 logs are in the bottom rows, 19 in the next row, 18 in the row above, like and so like and forth. The total log is equal to in how many rows are the 200 logs be placed. So we have the total logs is 200. Arrangement from an AP, first is A20, next is minus 1 is the D. Let the number of rows is equal to n. So we'll solve it. Sn is equal to 200. We have to find the value for the 200. Solve it. We'll get the total number of rows as 16 or 25. Next slide. So we'll put that value to understand if is it possible to have the two values of 25 and 16. When you put the value of 25 in the series, the value is minus 4, which is not possible, and hence the answer is 6. So for 16 value, we have to find the value of an, which is equal to 5 here. So in a potato race, the bucket is placed in the starting point, which is 5 meter from the first potato, and the other points are placed 3 meter apart. So we have common difference as 3 as 5, and total is in 12. When we solve it, we'll get the total value as 370. So typically, so these are like day-to-day problems wherein we have A being identified, we have D being identified. We know that this is an AP series, and we can use the logic and the formulas to get the value for the respective questions. So move to the next slide. Okay, now we get to the next and last exercise for AP as per the NCRT. So this is exercise 5.4, and we have to solve this as well. So which term of the AP is the first negative term? So we have know that negative term has to be less than 0. So first we have the A and we have the common difference minus 4. So we have to first find the general term. So we have to find the A, and when you put the value of A and D, we get the general term as 125 minus 4n. Then we have to put that 125 minus 4n should be less than 0. So when we solve it, we'll get the value of 31.25. So n is equal to 32. So when we try to verify this, so we'll verify for 32 and then we verify for 31 as well. So 32 term is minus 3 and 31 term is 1. So which means that 32nd term is the first negative term in this series. Sum of the first and the third and seventh term of the AP is 6 and their product is 8. So we have to find the 16th term. So we have given that sum of A3 plus A7 is 6 and A3 into A7 is 8. When we try to put this in equation and solve it, we get the value of D as 1 by 2. We move to the next slide to find the value of A and the rest of the solution. Okay, so we have given D as 1 by 2. When we put that value and substitute that value for both 1 by 2 and minus 1 by 2, we have the respective value for the A, which is either 3 or A is equal to 1 or A can be 5. And then we can find the value of 16th term by using A1 and D1 by 2 and A5 and D1 is 1 by 2 to get the two separate values. Now in the next question, what we have given is a ladder has a rungs of 25 centimeter apart. Rungs decreases uniformly in the length of 45 centimeter as the bottom to 25 centimeter at the top. Top and the bottom rungs are 1 by 2, 1 by 2 meter apart, which is the length of the wood required for the rungs. So what we have to do, we have to find the total value. So distance between the rungs is 25 centimeter. When we convert into the total height into meter into centimeter, we have 250 centimeter. So number of rungs is 250 by 25, which is equal to 10 here. Now bottom rung is 45 centimeter, top rung is 25 centimeter. So we have a total of 10 rungs. So length decreases uniformly in the form of the AP. So we have to find the first 10 terms. This A is equal to 45, L is equal to 25. When we solve it, we get the final answer as 350 centimeter. When we convert into meter, we get the value of 3.5 meter. Okay, so now we'll try to solve this question as well. So what we have given, we are saying that the number of the houses of a rows are numbered consecutively from 1 to 49. So they are numbered from 1 to 49, and there's a value of x. So such that the sum of the numbers of the houses preceding the house number x is equal to the sum of the number of the houses following the x. We have to find the value of x. Okay. So what we have to find, sum before x is equal to sum after x. So we have to use this formula. So we have given that sx minus 1 is equal to 49 minus sx. So xx minus 1 is equal to Sn minus sum of x. So first of all, we have to use the formula here to find the sum of the first n natural number. So this is a formula to find the sum of the first n natural number. We'll use this formula to find the value of sx minus 1. So when we substitute the x minus 1 in the place of n, so x minus 1 and then x minus 1 plus 1 becomes x. So x minus 1 upon x is equal to 2. So this is the value of the sx minus 1 here. Okay. Now we have to also find the value of 49. So when we put the 49 here, we get the final value of 1225. So sum of the first 49 term is 1225. Okay. And now we'll find the first x term. So first x term is equal to x into x plus 1 by 2. So which means that sum of the first x term, which is equal to x minus 1 by x by 2, is equal to 1225. So when we try to solve this value, because we have taken sx minus 1 is equal to 1225. When we solve this value, we'll get the value of sx minus 1 is nothing but sx minus sx minus 1. So when we try to solve this, x minus 1 by x by 2 is equal to which is the sx term, which is equal to the sx minus 1 term. So 1225 minus x into x plus 1 by 2. When we solve this entire equation, we'll get the final value of x is equal to 35. So again, what we have to do again, please, we have to be very much sure that we should understand it properly. So first of all, we have to find the sum of the first 49 terms. So sum of first 49 term is 1225. This is clear to us. Now, what we have to do in this step 3? So we are saying multiply by 2. So basically, the intention here is that we should get rid of the denominator. That is the entire intention. Otherwise, there is no point to his multiplication here. But what is this then? What is this? So we'll try to understand this equation in detail. So what we are saying is that sum of the x term is equal to 1225 minus what? So this is the 49 term. This is 49 term. So what we are given that sx minus 1 is equal to s49 minus sx. So s49 is equal to 1225 minus sx. This is my sx. This is my sx. So s49 is equal to 1225. We got it from here. Then we have sx, which is the value when we put here, we get it from here. This is equal to sx minus 1. So this is my sx minus 1. So we are using this hint to solve this equation. So when we solve this equation entirely, we get the value of x is equal to 35. And then we'll verify this by substituting the value. When we look at the sum before 35, which is 34 term, answer is equal to 595. And then when we have to find the rest of the value, so we'll subtract sum of the 49 term from the first 35 term. The rest of the value is equal to 595. So in this case, value before 35 term is equal to 595 and value after 35 term is equal to 595. So we'll move to the next question. Okay, so we have come to the last question of this exercise. So what is it that we have given a figure here, and then we have to find a total volume of the concrete that is required here. So we have given total steps as 15 here. Length of each step is 50 meter. That is given here. Rise is 1 by 4 meter, and thread is equal to depth is 1 by 2 meter. Okay, now the height is going to get increased by 1 by 4 meter with every steps. So it is 1 by 4 for this, 2 by 4, 3 by 4. Likewise, the total length will increase by 15 by till 15 by 4, because this is the total steps that we have. 15 steps are there. Now volume for each step is equal to length into breadth into height, which is equal to length we have given as 50 meter for each of the steps. So it is uniform. Likewise, breadth for each step is given as 1 by 2 meter, but the height is 1 by 4 for 1, 2 by 4 for second, and likewise 15 by 4. So this is the common factor that we have put. When we solve 50 by 2, we have 25. We have taken 1 by 4 as a common factor here, and then we have the 1 plus 2 till 50. Then we'll use the formula to get the sum of the first natural numbers, so n into n plus 1 by 2 formula. When we solve this, we get the value of 120. So 25 into 1 by 4 into 120, so total volume is 750. So we require this much of the concrete to create the entire steps. So we come to the end of this chapter. Okay, so as we come to the end of this chapter, let's quickly recap what we have learned and what is something that we have to going to remember. So an AP is a list of the number in which each term is obtained by adding a fixed D to the preceding term, and this is how we can form an arithmetic progression. Is A plus D, A plus 2D, etc. A given list of the numbers, we have to find the value, and then if it is value is same for the series, then this is an AP term. If we have to find any term in the AP, we can use the formula A is A plus n minus 1D. And to find the sum of the series, we have to use the formula S n by 2A plus n minus 1D. If the L is the last term and the series is finite, we can use this formula to get the value of the sum of the terms is equal to S into n by 2 is A plus n. And then if we have to find the sum of the natural numbers, we can use the formula Sn is equal to n into n plus 1 by 2 as well. So this is how we can use the AP to solve the problem. Let's move to the concluding slide and see what is it that we're going to do in the next chapter with. Okay, so as we come to the end of our journey through arithmetic progression, we have seen how simple patterns of numbers can help us to understand and solve a wide range of the real life problems. From arranging the objects and calculating the sum of the models, modeling steady growth and the decline, we explored how sequences follow a fixed rule and how to find any terms using the formulas, and how to effectively and efficiently calculate the large sum without adding each term individually. More importantly, we learned to recognize the pattern and think logically, skills that are essential not just in mathematics but in everyday decision making. Now, as we move forward, we transition from the patterns in number to the pattern in the shape, and in the next chapter, similar triangles, we will explore how figures can have the same shape but different sizes, and how the sizes and angles are related through proportional reasoning. So this shift from take us from the numerical pattern to the geometrical relationship, helping us to understand the concept and that are widely used in the fields of architecture, design, and even the photography as well. So let's carry forward our analytic skill and step into the fascinating world of geometry with the similar triangle. So we're going to come to the similar triangle as the next chapter. Thank you for watching this video and have a nice day.